Okay, my next problem, I have this table, and this table shows the populations for two cities, San Diego and Detroit, for these different years, 1950 to 2000. And I want to figure out when were these populations equal and what the population was. Now, looking at my table, I can kind of estimate about where I think the populations probably were equal. Like I see San Diego's population's increasing and Detroit's population is decreasing. So my estimate, well, probably somewhere around here, 1980, 1990. That's probably around when my populations were equal. But how am I going to find out when? We can do this process called linear regression. And linear regression will fit a linear function to model this data. And it won't fit perfectly, but it will fit our data pretty close. So I want to go through that process with San Diego's population and also with Detroit's. That'll give me an equation that we can then find where the two lines intersect. All right, so to our calculators now, let's go through the linear regression process. So we go on our calculator to stat and then edit, and you should have an L1 and an L2 here. If you have numbers in this column like I have, go up, scroll up to the L1, hit clear, enter. Do not hit delete, clear, enter. And that should clear all your data here. So we're going to enter all of our years in one column and all of San Diego's data in the next column. Okay, now for my years though, instead of using the years 1950, 1960, 1970, because that makes us work with some pretty large numbers, I'm going to call 1950 year 0, and then 1960 is year 10, 1970, 1980, 1990, 2000, and then I will flip back to here. Yep, so we only go up to 2000, and then again, San Diego's values, we're going to put in that L2 column. So go ahead and do that. I'll leave this up here, and I will type them in my calculator as well. All right, and here we are. So after we have our data in our calculator, here is what we are going to do. All right, I'm going to go to stat again, stat, over to calc, and then scroll down to this linreg ax plus b. Okay, so right now I'm just going to kind of write down our process again. For linear regression, stat edit to enter data, stat calc linreg to get your equation. So stat calc linreg, I hit enter, scroll down to calculate, and here's the cool part. My calculator gives me this equation, fits in this form up here, y equals ax plus b, and that is going to model San Diego's population. Okay. So San Diego's population is going to be 17,816. I'm going to go to the thousandth, so 5.597 x plus 356,896.238. All right, now we can do the same process with, what's our other city we're looking at? With Detroit. So we'll go back to, there we go, back to stat edit to enter in our calculator's data. So stat edit to enter, and my X values here, I really like those X values still. We're working with the same years. Go up to L2, again, clear and enter, do not hit delete. And then we can enter in Detroit's Y values here, Detroit's populations. So again, go ahead and do that. I have my data typed in, so we'll finish our process here. My data is typed in. Again, we go to stat, calc, lin, reg to get our equation. Stat, over to calc, scroll down to lin, reg, and calculate. So this will give me my other population. Oh my goodness, Detroit. So Detroit's population is modeled by this equation here, negative 19,000. 217.551x plus 1,849,401.619. Now, neither of these equations are going to fit our data perfectly, but hopefully they are pretty close. I forgot my y equals there. All right, now looking at our equations here, I'm going to guess that it might not be a whole number where these cities have the same population. That's where this process that I'm going to show you on the calculator is really handy, because with a table, it's pretty easy to see if the intersection point is a whole number, but a little harder if we have a decimal. So what we're going to do, kind of a similar process to how we got started before, we go to y equals and type these equations in. So San Diego, I'm going to type in first. And then Detroit after that. Negative 19,217.551x plus 1,849,401.619. Okay. The way I am going to solve this on our calculator is to graph. I'm going to look at a graph. And right now, who knows where these functions are? And we have really big y values. That's all we know. So a way that I can easily find my y values is to go to Window. I know my x values. I'm looking at the years 1950 to 2000, which, since we called 1950 year 0, is really going from 0 to 50. So I'm going to have my x min be negative 10 and x max be 60, just so I have a little wiggle room there. After I set my x values to what I know they are, go to zoom and all the way at the bottom. is zoom fit. This will set our y values to match the x that we have chosen. And it helps us see that intersection point. So again, here is our process. Type our equations in y equals and graph. Window, set your x min and x max. Zoom fit. And that gave us this nice picture. All right, my intersection point's here. Now I could kind of estimate about what it is, but I could also have my calculator figure out that intersection point for me. And here's what I want to do. So I go to second, calc, intersect. Second, calc, intersect. And it will say first curve. That just means my first curve, I'm on my blue line here, and that would be San Diego's population. So when I get close to that intersection point, I'm going to hit enter. Second curve, I'm on that red line, I'm on Detroit's population. Again, when I'm close to the intersection point, hit enter. And then it says guess, hit enter one more time. Okay, here is my intersection point. So it's after when x is 40.3. So to answer our question, after 40.3 years, which would be the year, well, we called year 0, 1950. So this would be 1990. Our populations are equal, and our populations would both be my y value here. So that's 1,074,919. And that 0.2 probably doesn't really matter because I don't think we have 0.2 of a person. So it's a long process here, but the intersecting process on our calculator will help make that process a little bit easier, especially when our intersection's not a whole number.